In the C and C++ programming languages, an inline function is one qualified with the keyword inline. This serves two purposes. Firstly, it serves as a compiler directive that suggests, but does not require, that the compiler substitute the body of the function inline by performing inline expansion, i.e., by inserting the function code at the address of each function call, thereby saving the overhead of a function call. In this respect, it is analogous to the register storage class specifier, which similarly provides an optimization hint. The second purpose of inline is to change linkage behavior. The details of this are complicated. This is necessary due to the C++ separate compilation plus linkage model. Specifically because the definition, body, of the function must be duplicated in all translation units where it is used, to allow inlining during compiling, which, if the function has external linkage, causes a collision during linking. It violates uniqueness of external symbols. C and C++, and dialects such as New C and Visual C++, resolve this in different ways. Problems. Besides the problems with inline expansion in general, inline functions as a language feature may not be as valuable as they appear, for a number of reasons. Often, a compiler is in a better position than a human to decide whether a particular function should be inlined. Sometimes the compiler may not be able to inline as many functions as the programmer indicates. An important point to note is that the code of the inline function gets exposed to its client, the calling function. As functions evolve, they may become suitable for inlining where they were not before, or no longer suitable for inlining where they were before. While inlining or uninlining a function is easier than converting to and from macros, it still requires extra maintenance which typically yields relatively little benefit. Inline functions used in proliferation in native C-based compilation systems can increase compilation time, since the intermediate representation of their bodies is copied into each call site where they are. The specification of inline in C99 requires exactly one additional external definition of a function in another compilation unit, when the corresponding inline definition that can occur multiple times in different compilation units. If that function is used somewhere, that can easily lead to linker errors because such a definition wasn't provided by the programmer. For this reason, inline in C99 often is used together with static, which gives the function internal linkage. In C++, it is necessary to define an inline function in every module compilation unit that uses it, whereas an ordinary function must be defined in only a single module. Otherwise it would not be possible to compile a single module independently of all other modules. In embedded software, oftentimes certain functions need to be placed in certain code sections by use of special compiler instructions such as pragma statements. Sometimes, a function in one memory segment might need to call a function in another memory segment, and if inlining of the called function occurs, then the code of the called function might end up in a segment where it shouldn't be. For example, high-performance memory segments may be very limited in code space, and if a function belonging in such a space calls another large function that is not meant to be in the high-performance section and the called function gets inappropriately inlined, then this might cause the high-performance memory segment to run out of code space. For this reason, sometimes it is necessary to ensure that functions do not become inlined. Language support. C++, C99, and New C each have support for inline functions. Different compilers vary in how complex a function they can manage to inline. Mainstream C++ compilers like Microsoft Visual C++ and GCC support an option that lets the compilers automatically inline any suitable function. even those not marked as inline functions. An inline function can be written in C or C++ like this. Then, a statement such as the following will be translated into, when implementing a sorting algorithm doing lots of swaps. This can increase the execution speed. Microsoft Visual C++ specific. Microsoft Visual C++ and few other compilers support non-standard constructs for defining inline functions, such as __inline and __ force inline specifiers. The __ inline keyword is equivalent to inline. The __ force inline keyword allows the programmer to force the compiler to inline the function. But indiscriminate use of __ force inline can result in larger code, bloated executable file, minimal or no performance gain, and in some cases even a loss in performance. The compiler cannot inline the function in all circumstances, even with the __ force inline keyword applied. If the compiler cannot inline a function declared with __ force inline, a warning of level 1 is generated. A list of cases when __ force inline will not take effect is listed below, based on Microsoft's specifications at MSDN. The function or its caller is compiled with ob0, the default option for debug builds. The function and the caller use different types of exception handling. C++ exception handling in one, structured exception handling in the other. The function has a variable argument list. The function uses inline assembly, unless compiled with OG, OX, O1, or O2. The function is recursive and not accompanied by #pragma inline _ recursion. On. With the pragma, recursive functions are inlined to a default depth of 16 calls. To reduce the inlining depth, use inline _ depth pragma. The function is virtual and is called virtually. Direct calls to virtual functions can be inlined. The program takes the address of the function and the call is made via the pointer to the function. Direct calls to functions that have had their address taken can be inlined. The function is also marked with the naked __ equals spec modifier. __ force inline is useful if inline or _ inline is not respected by the compiler. Ignored by compiler cost-benefit analyzer. Code portability is not required. Inlining results in a necessary performance boost. Example of portable code, quotes. A function declaration with an inline specifier declares an inline function. The inline specifier indicates to the implementation that inline substitution of the function body at the point of call is to be preferred to the usual function call mechanism. An implementation is not required to perform this inline substitution at the point of call. However, even if this inline substitution is omitted, the other rules for inline functions defined by 7.1.2 shall still be respected. Quote, ISO, IEC 14882. 2011. The current C++ standard. Section 7.1.2. A function declared with an inline function specifier is an inline function. Making a function an inline function suggests that calls to the function be as fast as possible. The extent to which such suggestions are effective is implementation defined. Footnote. For example, an implementation might never perform inline substitution, or might only perform inline substitutions to calls in the scope of an inline declaration. Quote, an inline definition does not provide an external definition for the function, and does not forbid an external definition in another translation unit. An inline definition provides an alternative to an external definition, which a translator may use to implement any call to the function in the same translation unit. It is unspecified whether a call to the function uses the inline definition or the external Definition. Quote, ISO 9899. 1999. E. The C99 standard. Section 6.7.4. See also. Macro. Computer science. Inline functions with the GNU compiler collection. GCC.